So yeah, we're here for the keynote, and this summer is when I just got introduced to NetsBlox, and I am super excited about it. Just even in the lightning talks we've had, I've gotten some ideas, and I am really excited to hear what Brian and Akos has to share with us about the overview of NetsBlox, and then what are the new features that are there. I know it's going to be a really exciting talk. So let me turn it over to Brian and Akos.
Thank you so much for that wonderful introduction, and thanks everybody who are taking time of their Sunday morning or afternoon to join this talk. So thank you so much. Let me share my screen. All right. Okay, so hopefully you can see my slides and not the notes page, right?
Yep, we can see your slides.
All right, thank you. So I'm going to kick off the keynote, and we're going to be switching back and forth with Brian, who is, of course, the main NetsBlox guy. I'm just here for the ride. So what do all these applications and apps and projects have in common? Okay. Let's see. Well, actually, two things. One is that our kids use, or most of our kids use, most of these almost every day. Okay, so that's one thing. The second is that none of these apps would work without the internet, right? They are all what's called distributed applications. They don't run in isolation. They need data and they need communication with other resources and computers on the internet. Okay, so that's kind of the opening statement, so to speak. So let me ask this question: do block-based environments have high ceilings? Definitely so. I mean, just this conference is so all the wonderful things that we can do with Snap. It's really amazing. And just like these beautiful gardens, the ceiling is literally the sky. But notice the walls, right? All of these have walls around them. And back to my previous statement, I mean, we can do wonderful things in Snap and other programming environments, but there is a whole wide world beyond those walls. And it would be really great if we could connect to things and use everything that's out there on the internet. So the suggestion is to tear down these walls. Okay? Now, of course, the Pink Floyd analogy only goes so far, because definitely teachers shouldn't leave our kids alone, and they do need education, but I wanted to make this analogy anyway. Now, I don't want to pretend that we are the only ones or the first ones to say that this would be really cool to provide access to the wide world of the internet. And there are, of course, many approaches that people are doing. Just this conference, we've seen several, right? There is the HTTP GET support, even in Snap, to get access to web APIs. We have seen wonderful demos how to interact with hardware devices. Of course, we have cloud variables. I think people have been, at least in Scratch, they have been abusing cloud variables to try to get some communication across projects running on different computers. Of course, many people are adding machine learning libraries. There is some collaboration support out there. So there are definitely cracks in these walls, but I guess what we wanted to address with NetsBlox is that there is no uniform support to accessing resources on the internet and communication across projects. So these approaches kind of, there's a mishmash of different ways of doing things, and it's not really a unifying kind of abstraction. Okay. So again, people have been widening the walls, and the primary ways of doing that in most environments are through libraries and extensions, right? But here is the problem. So every extension and library that you import brings in many, many new blocks, right? And so if I import all the Snap libraries, I literally have hundreds of new blocks, and it's kind of hard to keep track of them, hard to find them, hard to figure out what they do. So there is a scalability problem here. So what we try to do with NetsBlox is to come up with really simple abstractions and simple blocks that provide a very rich and powerful functionality. So everything that you are going to see today use standard Snap plus these 3 blocks, and that's it. There is nothing else, just these 3 blocks. Really, there are 2 new abstractions, okay? And by new, I mean old, because they have been around in computer science ever since distributed computing started decades ago. And one of them is called Remote Procedure Call, or RPC. And the basic idea is that there is functionality that running on a remote computer, in this case is the NetsBlox server, and let's run that code on the server and let's get back the result, right? So they are similar to custom blocks, but the code runs on the server, okay? They are self-documenting. So what do I mean by that? I'll show most of it during the demo, but even here you can see that the input arguments have their names show up. So for example, if you look at the first one, cloud variable, set variable, name, value, password, I mean, it's pretty obvious what those are and how to use it just by that, but I'll show more what self-documentation really means. So similar RPCs are grouped into services. So what you see here, cloud variables or translation chart, those are the services. And then the second pull down menu is the RPC that you can select from the pop-up menu, okay? And I always get this question, so this is basically just a wrapper around web APIs, but that's not true, and we'll see examples why not. They do more, and also there are some that are not web APIs at all. So for example, the chart service is GNU plot that runs on the NetsBlox server, so there is no additional outside service needed. So RPCs are one of the abstractions, and there is a single block, the call block, and then the second abstraction is message passing. They are similar to events, right? So the send message is like a broadcast, but it also contains data, okay? So it has a name just like events, but you can also provide additional fields, named fields that are data. And then also the big difference is that it doesn't stay inside the project. You can send the message to any running NetsBlox project anywhere on the internet. And of course, the when I receive block is the counterpart, and those data fields show up as variables. Okay. All right, so without further ado, let's look at some demos. Okay. So when you go to editor.netsblox.org, this is what you see, and what you see is basically Snap, right? Of course, we started from Snap. We are using the wonderful work of Jens and Brian and all the other people. And the reason is because it is great. So it was really easy for us to add just those few new things that we needed. And specifically, if you look at here, there is this network tab. And I guess there are a little more than 3 blocks, but really 3 main blocks. The rest is kind of just extra syntactic sugar on top, but basically it's just these 3 blocks that we need. So let's look at the call. Okay, so first of all, when you pull down this menu, you see all the services that you have access to. Some of them submenus like climate change and AI and stuff like that. So let's just pick one. This service provides the data provided by NOAA from the Hawaii Observatory. They have been measuring CO2 concentrations in Hawaii in the air since 1958. So I can select this RPC. So once I select the service, this menu reconfigures and shows the RPCs that belong to that service. And these 2 start year and end year are optional. So how do I know that? Well, I remember, but if I don't, I can just say help, and the help pops up and explains what those arguments are. And if I need more information, I click on this link, which takes me to the documentation page and explains exactly what's going on. So that's kind of what I mean by self-documenting. It shows the input argument names, it reconfigures the block, and it provides context-sensitive help. All right, so if I click this, here is the data from 1958, and this is CO2 in ppm, okay? So that's already pretty cool. What can I do with this? Well, why don't I chart it, okay? So I can select the chart service, and the draw RPC, it has lines and options. So I can just put this directly in the lines, and I can switch the costume to that. And here is the chart for the atmospheric CO2 concentrations from 1958 until today. If this was a climate change talk, we could talk about this really disturbing trend, but let's skip that for today. All right. So what if I wanted to create a weather application? Okay, so first of all, let me clear this costume. So let's create a map background on the stage. So I pick the stage, I go back to here, I select Google Maps, and I select Get Map. I have latitude, longitude, width, height, zoom. Okay, so they are kind of self-explanatory, and I can use the my latitude, my longitude, and stage width, stage height. And then the zoom level, as explained in the documentation, is actually a Google thing. It's a number between 1 and 25, an integer between 1 and 25. And so I can switch the costume to that. And my latitude, my longitude, go through the privacy settings, and for some reason it's fairly slow, but here we are. You can see that I am somewhere southwest of downtown Nashville. Okay, all right, so that's great. So when we start this project, we'll get this map. What I'm gonna do though is add, wherever I want to click, it will show the current weather conditions. Okay, so let's actually change the zoom level to 5 to have a bigger map. I'm also going to ask Brian to kind of add zoom capability to this map while I am doing the weather portion. So for that, I'm gonna invite him to collaborate with me. So here is Brian. I'm gonna invite to collaborate on this project. So he has a message that popped up on his screen. He will accept that invitation, hopefully, and join this project. And he's already starting to add code to do the zooming to this map. So while he's doing that, let's hop over to the sprite. So first of all, whenever I click on this map, the sprite should jump there. So in fact, I need to go back to the stage and say that when I am clicked, I'm gonna broadcast a message. And you can see that in the meantime, he's busy building his zooming. Okay, so map clicked. Okay, so go back to the sprite. So when I receive map clicked, okay, what shall I do? Well, let's move the sprite to the mouse pointer. There was a little bit of a glitch of collaboration, so sometimes if there is a change, it may get lost, but that was just a temporary glitch. So go to the mouse pointer. The problem is that the mouse pointer, the sprite will be on the screen, but of course the screen coordinates are not what we need, right? So we have a weather service, as you might have guessed. So here in the science weather, we have the weather service and we have the icon for the current conditions, but it expects a latitude and longitude, but I only have X and Y. Well, good thing that we have the Google Maps service. Let's see what we have here, where there is something called get latitude from Y. Okay, so now I can do that, and I can also get longitude from X. So now I can just go to the motion tab, get the X position here, get the Y position here, okay, and I can call the weather service with this. Okay, so now I will have the icons. All I have to do is switch the costume to that. Okay, so let's see what happens if I click on Atlanta. Well, it looks like it's cloudy in Atlanta. How about St. Louis? It's foggy. Let's see if we can find a sunny place. Here in Columbus, the weather is sunny. All right, so that's basically our very first weather app with just a few blocks of code. It looks like Brian did the zooming already, and he started working on panning, but basically he added a variable called zoom. And then whenever we hit the plus key, it will change the zoom level if it's not exceeding. Okay, and the only thing that's missing right now is that it doesn't update the map yet. So normally I would pick a custom block to do this, but in the interest of time, I'm just gonna be doing this. Okay, so now if I hit the plus, well, first of all, I need to restart it because the zoom wasn't initialized, right? So I need to hit the green flag to get the zoom variable set correctly. Okay, again, the altitude, my longitude, the my longitude takes a little bit of time. Okay, so now the zoom is 5. So if I hit plus, I should be zooming in, except this. Okay, again, just the speed is a little bit. And then if I hit the minus, I can zoom out. Anyway, and he is doing the panning. The panning is a little bit trickier, right? If you think about it, how much you pan depends on the current zoom level. But instead, if you think about in screen coordinates, you can just shift by half the screen. So in that case, it becomes independent of the zoom level. So that's what he is doing here. Anyway, I think in the interest of time, I am going to show a few quick demos. Okay, so here is maps on steroid. Okay, so first of all, there's a little bit of help here. Let me increase the size. Okay, so now it's showing my home actually. So let me zoom out a little bit. Maybe I'm gonna hop over to, let's see, the Wendy campus. So here is Vanderbilt campus. Let's click somewhere here. And here we are on the Wendy campus. I can look around. And so basically this is street view integration. You can have your very own street view. Okay, so if I type in Eiffel Tower, well, it's a sad state of affairs that it brings me to Las Vegas, but I can click there and hopefully find the Eiffel Tower somewhere here. Maybe I'm too close to it. Where is it? I'm too close to it. Where is it? Oh, there it is. Okay. All right. So how much of a code we need for that? I mean, it's definitely more than the one we were just working on, but it's still less than 100 blocks of code, and you have full street view integration into your project. Now, if you want to combine mapping and the data processing and data display, let's say, well, I need to start it. I don't think it was running. So this application displays COVID data. So if I click on Louisiana, it gets the data. It does some moving averaging from 7 days. And I keep promising myself that one of these days I'll speed this up because it takes a few seconds. But here is the up-to-date COVID data for Louisiana. Every day the data is refreshed from the Johns Hopkins database, and it's served via the NetsBlox server. So you can see that we are going in the wrong direction. We want to check out Japan, how they're doing with the Olympics. I can click on Japan, and again, a bit of a delay with the data processing. So this is not the NetsBlox server delay. This is actually my code being slow. You can see that Japan is not doing great either. All right, quick final RPC demo, just to show that you can do something different. Here, this one displays the leading actors of any movie. So if I type in a movie title like Star Wars, maybe I typed it, Star Wars. Okay, here we go, or I don't know, Black Widow, just out. Okay, so again, and you can see that the code in this case is fairly simple. For these sprites, this is just basically using this custom block, which is getting the images from the database and then in a loop, just looping through them and displaying them every 2 seconds. All right, so that was the quick demo. Now you may be wondering that, okay, so we are providing, let's say 50, 60 different services, but what if we have data? What if a teacher has data that they want to use in their class? What can they do? And so let's switch to Brian, and he will show you exactly how that can be done.
All right, so as Akko said, sometimes like we have a bunch of data sources and data sets already available in NetsBlox, but you might have some locally or some local data that you want to look at, or some data that's maybe more relevant to students, or just some data that we haven't gotten into the added to NetsBlox just yet. So to that end, we actually created a service for creating services from within NetsBlox. So if you have like a CSV or JSON or some other set of data, you can import it into NetsBlox and get a table view of the data. And then using this RPC, you can actually create a service that other students can use. So then many other people can have access to this data set as well. Now, the simplest way to do it is just to upload the data, and then NetsBlox will look at your data set and try to infer some meaningful RPCs. But if you are a more advanced user, you could, of course, write some code like the one in the kind of this set of orange blocks here, where you actually implement the RPC in blocks, and then this code, and then these blocks would run on the server whenever this RPC is called. Now we have a tutorial that's linked here, but I'm going to just jump into an example. So suppose, for example, I wanted to actually look at the Olympic medals that people have won during the Summer Olympics. I could go online and find this data set hosted by Kaggle, this machine learning competition website that hosts a lot of different data sets. And I can see that it actually has a data set that's like 2.5 megabytes of all the medals that have been won during the Summer Olympics. So if I download this, and I already have downloaded it, so I'll just skip that step. But if I download this data set, I have a couple blocks loaded here. I can simply import it into NetsBlox. And now we see this data set is available as a table in NetsBlox. So you can see the year in the first column, city, other information like the country and gender and medal. And now, before I actually create the service, I want to actually show where these types of services will show up, partially so that you can also see that I'm I am in fact creating it. So if we look at the services dropdown, there's this category called community, and the community services are organized by username. So you can see that I have 2 services right now: Brian's first service and a soccer service I made a while ago too. But if I take this table of data and I say I want to name this service Summer Olympic Medals, and I run this or call this RPC, it'll take a second, and then we'll see an OK, and we can see that it completed without error. And now if I look back at this call RPC block that we were looking at before and go under community, we can see Brian, and we can see Summer Olympic Medals. Oh, I should put an S in there too. Oh well. And now if we select the second dropdown, we can see all the RPCs that it inferred from looking at the data. So we can see get all the year values. So we can see that this data set goes from 1896 all the way up to 2012. We can also look at things like say we want to actually look at the number of medals that each country got for a given year. And let's pick the most recent one. So this is getting all the country values, or really the country column here for 2012. So you can see that we get almost 2,000 values. So 1,949 values. So you can see a lot of USA, China, Great Britain, etc. Now here I am going to use a custom block that I wrote earlier for the sake of time that simply goes through and counts up each item in the list. So I can get a dictionary of the country with the number of medals. So the number of times it showed up in the list, which corresponds to the number of medals. And now using the same RPCs that we saw before, specifically like the chart service, we can actually use the draw RPC and draw it. But now instead of having X, Y values, we're not plotting a single line. So I need a couple more options. I need to say that it's categorical and that I want it to be a box plot. And then I'm also going to set the width and the height to match the stage. And I'll add a little title in here too. So Olympic medals by country in 2012. All right, and now if I pass this as the set of options, when I call this, we'll see a little figure, and I can actually switch to the costume like before. Now I can see that we actually have this plot. The x-axis is a little bit jumbled, so I can actually increase the stage size. And now let's recall this. And here we go. And now I've been able to actually create my own data set and then actually do some data visualization with this newly created data set immediately after. And the most important thing here is not just that I have this data like on this browser, but if Akos wanted to create the same thing or any of you wanted to create it, you simply can pull in this call RPC block, and this RPC or this service, this Summer Olympic Medals service, will be available under the communities category or community category as well. All right. And we have a tutorial, as I mentioned before, that's available as a NetsBlox project itself that kind of walks you through all of the steps, starting from creating your first service, just like we just did, but then going into some of these more advanced cases, like implementing your own RPCs in blocks that, given the data, do whatever sort of processing that you'd expect, and then return the expected results to the user. Now this, I'm going to kind of transition a little bit and jump into some of these message passing demos. So we have a few different, there are a lot of different things we can do with message passing. So like we can start with simple things, like perhaps the simplest is just a distributed hello world, which has two different clients. So in NetsBlox, we added this room tab where you can actually see two different clients in a single project. So in this case, these are like each individual, like the listener or the speaker is like an individual Snap project. So they have their own stage, they have their own variables, they're completely independent of one another, except they can easily kind of see each other and send messages to one another. And I can see if who else is occupying it. So you can see that I'm currently at the listener role, and no one is in the speaker role. If I quick move to this role, we can see that this one just has two blocks. It's sending a message that says hello world to the other role, and the listener role simply says that message on the screen. So I can invite Akos here, and as soon as he accepts this invitation, we can see that it shows that he's actually at this role. And if he presses the green flag or runs those blocks, we can see that he sent me a message called hello world. So this is the simplest one to get started with, just to show that even when introducing this network, these message passing concepts that are, again, running over the network, we're still keeping a pretty low threshold. That said, though, we do have more. They also, like the spirit of a lot of the other features that have been added to Snap, such as like these first-class functions and such, we also have a very high ceiling with message passing. So for example, with very few blocks, we can actually create a chat application. So I just posted one of the links in the chat, so if anyone wants to be brave and give it a whirl, the chat client. So here we go. Let's hop over to the server. So this is a project where we have a chat server and a chat client. And on the chat client, when you run the project, you can hit space to send some message. And when I say, and when we send these messages, we can say, oops, there we go. We can actually see these messages being sent through the server. And we can see them showing up on every client. So if you are looking at, there we go. So if you logged in and clicked on that link, you should be able to see all of these messages being sent as well. So you can see a bunch of people are having an active conversation here. All right. So and to kind of reiterate some of the same things that we saw with the RPC demos, this chat client is actually relatively simple. It's just, I don't know, maybe 30 blocks. Basically, we're registering ourselves with the server, and then we have some blocks for actually printing everything on the screen and the ability to connect to different chat servers. The chat server itself is even simpler, and we basically just keep a list of everyone who's connected, and then we can send messages to each of them, or we just kind of relay the messages that have been sent. Now, one of the things that I particularly enjoy about this, when we're actually in like the classroom or working with students, is that this actually creates a really nice environment where we can start talking about things like cybersecurity or denial of service, because it doesn't take very long, oftentimes, where a student might start putting one of these in a forever loop and send some sort of message to everybody. So like, anyway, so I could send like the time, or hi, and exactly now I'll start seeing that I'm just kind of spamming the server with a bunch of chat messages. So I think that one of the things that I like particularly around this is that you can really motivate a lot of these topics that are sometimes hard to get to otherwise, using these simple abstractions. And sorry to everybody for spamming their chat clients. So these were two different applications of kind of increasing complexity where we're introducing messages. Now there is one more here that I'm going to jump into, and that one is just a little bit more of a creative use of this of message passing. So this is an application that is like the others, still relatively simple. Like we're not really worrying about any unnecessary complexities. And we're kind of focusing on the details of this, but this is a shared whiteboard. So I can invite someone, so I can invite like Akash again. And with relatively few blocks, we can actually have this whiteboard where I can draw, and then you can see Akash drawing. I'm not exactly sure what it is yet. A bird? Looks like a bird. So anyway, so with relatively few blocks here, we're still able to build a really interesting and engaging application, but not to the point where we're actually hiding the actual complexities. So like, for example, like we could actually, not to jump into this too much, but we could actually inspect some of these, like the messages that are being used here. We can see that we're sending a list of X and Y coordinates and things like this. So it's not abstracted away to the point where it's trivial, but it's abstracted away to the point where students can actually focus on the questions and problems of interest, which I think was super exciting. Okay, so now, before we continue into some more of the demos, which we have coming up here, I wanted to talk just a brief moment about some of the NetsBlox architecture pieces. So NetsBlox, basically these RPCs and messages are all going through the central server. These RPCs are all made available, or all these sets of services really, on the core part of NetsBlox, which gives you access to GNU plot or cloud variables or service creation. And sometimes these services will reach out to other APIs like Google Maps or Microsoft Translate or the MovieDB. And other times we'll be connecting out to maybe like educational robots, which we'll see in a moment, or mobile devices, which we'll also see in a moment, and voice assistants, which will be coming later as well. And then of course, all the message passing and things are made a bit easier by NetsBlox by giving some kind of flexible routing rather than worrying about learning IP addresses and worrying about firewalls and some of those other additional complexities. Now, with that, I wanted to actually hand it back to Akash, and he's going to start showing us some of the recent work with using your phone as a sensor in these distributed programs.
Thank you. All right. So we have seen some cool demos yesterday about connecting microbit blocks and other hardware devices, and that's great. People have been doing that, and I'm an engineer. I really like these hands-on things, but many high school teachers are not engineers, or most of them are not engineers. Some schools don't have budget for hardware, and there are all kinds of other issues. Most students don't have hardware at home, but close to 90% of students in the US at least, and I assume in most developed countries and even developing countries, have a phone which has a bunch of powerful sensors, and the phone that is already on the internet out of the box. So you don't need cables, you don't need to install Bluetooth drivers or anything like that. You have a hardware device in every student's hand already. So why not use it? Okay? So that was kind of the motivation behind this work. So here we created an app called Phone IoT. It's an iOS and Android app. It's freely available from the App Store. By the way, this is Devin's work. He's a graduate student at Vanderbilt. And what it does, it provides access to all the sensors that the phone has to NetsBlox. Okay? And since the phone already has a display, not just LEDs, but an actual high resolution display, we make use of that as well. So NetsBlox can put buttons and other GUI widgets on the screen. Okay? And you can interact with these through the NetsBlox messaging. And that's actually kind of the point. So whenever we added support for educational robots or phones or whatever it is, we didn't have to change anything on the client. The client code is the same. There are no new blocks. We still use the message passing and the RPCs, and that's it. So just a couple of examples. And I guess the main point is this is not an app development platform, right? So the code still runs in the browser. It's an NetsBlox project. It just communicates with the phone IoT application that runs on the phone. So again, not an app development environment. Okay, but here's an example. For example, if you look at this middle picture, this is the phone screen showing an exercise tracker, right? So what it does is that it gets the location from the phone, and whenever the user hits the start button, it starts counting the distance. Whenever the user hits the stop button, it stops, and it refreshes the image with the track of the user. So on the stage in your computer, you will see a Google Maps, and using the pen, it just shows your track, and then every second you update that image on the phone as well. Okay, so you can go on a run and basically have your exercise tracker. Okay, all right, and here is another one that's actually almost the same as the demo we saw from John yesterday, using the acceleration, just basically plot that on the screen. So let me switch to demo mode again. Oops. Okay. And hang on, I think I have this somewhere opened already. Yes, okay. All right, so this is the acceleration plotter app. So each device has a unique ID. You can set a password. Right now, I set it to 0, so there is no password. So you set the credentials. Then basically, I'm listening to the sensor, the accelerometer specifically, and every 100 milliseconds. So then I'll just update the screen every second. And here is the message. So the phone will send me a message every 100 milliseconds with the X, Y, and Z acceleration values, which I just add to a list with the actual current time. Okay, so if I do that, let me make sure that phone IoT works. Okay, so I don't know how well you can see my display. It's actually blank. It doesn't show anything, right? Because we haven't put any user interface elements on the screen. But if I start this, okay, it's connected to my phone. So if I'm holding it kind of motionless, it's auto scaling. So you see some variations, but let me flip the phone over. Okay, so now you can see that all of a sudden the Z coordinate is -10, well, 9.81 G, right? And if I flip it back, it will go back to +10. If I set it on the other edge, now you can see that now it's the Y that is 10, and so on and so forth. If I shake the phone, then you will see all kinds of wild gyrations. All right, so that's one quick app, just showing how to access the accelerometer. Another one is we call the drop game. Let me show you how that works. So if I hit the green button, well, I don't know how well you see this, but you see a big green button says new game and also a text label that shows how many games I won or lost. So basically, I just lost one because it fell, the sprite fell in the hole. But what I am doing, I'm gonna hit the new game and I'm gonna try to get to the green flag on top by tilting my phone carefully. I used to be better at this. Okay, all right. Can I make it? Oh no. Anyway, you get the idea, right? So again, gaming with the phone using NetsBlox. So what's the code? The code is similar to this. We'll just set the credentials and the user ID. We listen again to the accelerometer. And here we add the new game button, the correct coordinates and colors and font size. And we also add the label that shows how many games are won or lost. Right now it's a decimal 0 out of 2 record that I have on my screen. All right. So you can do all kinds of other things. In a minute, I'll show you how to turn your phone into a game controller. But next, let's talk about robotics. Okay. So we do it a little bit differently than other environments. We use Wi-Fi enabled robots, right? So these robots, in this case, this is the activity bot from Parallax. They are connected to the Wi-Fi. They don't need a local computer to connect to the internet. So they directly connect to the internet. So that's great because what we can do is actually have them connect to the NetsBlox server. And now we have access to these robots. And we can, using RPCs, send commands and get back sensor value. So again, the code runs in the browser. We don't have to download any code. There are no wires. There is nothing to connect to. They are just on the internet and they accept these commands and send messages. And the added twist is that these wireless commands can be intercepted by the other students. So they can hijack my robot. And that, of course, introduces the need for cybersecurity. So we have used this platform to teach all kinds of interesting cybersecurity concepts like encryption and denial of service and so on and so forth. Okay, so just, of course, right now, the robot that I had here did not connect correctly to the internet. Let me see whether it will connect after a reset. Whether here is the robot. And of course, this worked perfectly before the keynote when I tested it. Let's see. So it's actually supposed to connect to my phone as a hotspot. Okay, I think we are in business now. All right, so if you can see, this guy has an address of 6703. Okay, so we're gonna use that to try to control it. Okay, so here is NetsBlox again. What I'm gonna do is actually create a new variable called robot. Okay, well, I guess I'll set that robot to 6703. Okay, all right, let's do it correctly. All right, and now what can we do with this? Well, again, here is the version of the call block that is not a reporter is called run, of course. So let's just use that for version. Here is Roboscape, our robot service, and we can send commands to the robot. So what commands? Well, let's do beep, 500 milliseconds, 500 hertz. So if I run this, you should hear, hopefully you did hear that beep, okay? What else can we do? Well, what I usually do is immediately create an emergency stop button. So I say set speed 0, 0. So whenever I hit the space key, it should stop. But let's maybe with the right arrow, let's try to turn it, spin it in place. So one wheel is going to be at minus 50 and the other at plus 50. So it should spin in place when I hit the right arrow. So hopefully you can see this. See how the wheels are turning. So if I hit space, it stops. And just again, just look at the latency. I'll hit the space really hard so you'll hear when I hit it and see how fast the wheel stops. So there is about 100 millisecond delay to drive these robots. Somebody is hacking into my robot and just beeped it. But that's why we have encryption and other things that, of course, we don't have time to get into right now. All right. So we have done multiple camps where students come in on Monday, some of them not even knowing anything about programming. We teach them NetsBlox, we teach them RPCs, message passing, and then the robots, and then cybersecurity. And then on Friday, they do something like this. Let me, hopefully where is that? Too many tabs. Yes, so here is a brief video of the camp. So at the end of the camp, they had to write a robot control, a manual driving remote control app, and they had to push these boxes into a target area, and whoever pushed the box through first won. And everybody else was allowed to try to hack their robots. And I was playing the goalie under this chair to try to mess with them even more. It turned out that I wasn't a very good goalie, but you'll see. And they could push any box in there. They didn't have to push their own box, so they could hijack other people's boxes. All right, so they were having major fun. But my previous comment about hardware being problematic is still valid. So these robots, even though they are fun, they are about $250 and they break easily. So if a teacher doesn't have the budget or the time or the willingness to spend a lot of time to maintain these robots, that can be a problem. And then of course we had the pandemic come in. So what we did, we expanded this idea into the virtual world. So we created this virtual robotics platform, okay, that works exactly the same way as the physical robots, except students can join remotely the same world and compete or collaborate to solve robot challenges. Again, time is running short, but just a quick note. So you can build any kind of robots you want. So you are not restricted to $200 robots. You can build a $2,000 robot because it's basically free, right? And then also you are not limited to robotics. So Gordon, who is building this environment, also created like this smart city thing where you have vehicle sensors and the students have to write NetsBlox code to control the traffic lights. The vehicles are generated by the environment and they have to control the traffic lights so that they implement a fair scheduling algorithm, but also which has a good throughput. So I think we only have time for a really brief demo. Okay, so here I start this environment. I have to log in with my NetsBlox credentials. Okay. Now here it is. I have 3 robots right now. I can kind of navigate and look around. So let's see, here is this robot 5F75. So let me just bring up my previous code. here and change this to 5F75, okay, and run this. So let's see if I hit the, no, I have to move the window so that we can see everything. So let's, okay. So here, if I hit the right arrow, you can, well, I guess I'm turning left. I messed up the arguments. If I hit space, it stops. Okay. So the exact same code that I just ran on the physical robots run in this world. And if we had more time, I would ask Brian to connect to this other robot, and then he can drive his robot in the same world as I am driving mine. He's in Minneapolis or Minnesota. I'm in Nashville. So that kind of works really nicely. And we had several summer camps in June, where students again came in with knowing nothing about NetsBlox. They were able to use both phone IoT and this environment. I was going to show this demo as well, but we are running low on time, so I'm going to skip the demo part itself. But this is the entire code, and this was, by the way, their final project. So they had to create a phone controller, a remote controller for the robots. So this is the entire code. Okay, it displays these two joysticks and two buttons on the phone screen. With the joysticks, you can drive the left and right wheels of the robot. And of course, this is the robot that runs in that world. This part of the code sets up the user interface and connects to the phone and to the robot. And this is the message handler. So for example, the Joy1 message handler will just set the left speed based on the Y coordinate of the joystick, or the beep will just send the beep command, and so on and so forth. So unfortunately, I don't have time for an actual demo. So instead, I'm gonna give it back to Brian to continue his part.
All right, so in the remaining 6 minutes, I'm going to talk about a couple other exciting new integrations with NetsBlox that are made possible by trying to break these walls down and build on top of this RPC abstraction. So one of which is the ability to create Alexa skills from within NetsBlox. So basically, voice assistants are pretty ubiquitous. You can find them everywhere. So you can use your voice to control things ranging from your car to your phone to even your thermostat. So it seemed like a great opportunity to try to make programming these platforms possible from within NetsBlox. So a familiar blocks-based programming environment. And as NetsBlox inherits things like first-class functions from Snap, you're able to actually define skills in a very rich way. So we have an example here on the right where we're building an intent. That's a greeting intent, and we say that it's a greeting intent is something where the user says like, please greet with a person, or say hello to some person, or greet a person, and where the person is a person, where the person's spot here is a person. And then this function here at the bottom is actually what is run when this intent is invoked. In other words, if I would say to Alexa, say hello to Brian, it should say greetings, Brian. Now I did make a little change to the one on my phone, so it'll say hello, Brian instead. But I can still demonstrate. Alexa, tell my skill to greet Brian. Say hello to Brian.
Hello.
Oh, 1 second. Tell my skill, say hello to Brian.
Hello, Brian.
So we can build these kind of simple Alexa skills, but this is actually just like the tip of the iceberg, because when you start combining this with these other features, message passing and the many other RPCs that are available, you can do much more sophisticated things like say send messages to another NetsBlox program. Tell SnapCon example to spin.
No problem.
Tell SnapCon example to draw a square.
Of course.
So we can do things like this, where now we're actually building an Alexa skill, which actually uses NetsBlox messages to send messages to other projects and be part of this broader distributed application. All right, so now in the sake of time, I'm actually just going to hop over to the last the demo that I'd like to show, and this is about auto-graders. So I think auto-graders are an exciting topic to integrate into NetsBlox because of course they're practical for independent study, MOOCs, etc. But one exciting thing about the auto-graders in NetsBlox is they're not just for NetsBlox, but they're created in NetsBlox as well. So we have a curated set of exercises, and so this is, actually, if I go to this URL here, this is a version of NetsBlox with the auto-grade, with a bunch of auto-graded activities loaded. I can see a puzzle piece in the corner and select one of these exercises. So I could select things like, say, working on counting letter frequencies. And then it'll load a template project to start with, right? It counts letters in some text with an example and an extension piece here where it's actually giving you the frequency distribution of different letters in the Adventures of Sherlock Holmes, which uses a different service that we have to fetch a bunch of classic texts. And this one is available as a Parsons problem, and I can grade it, of course, right here. So I could work on this if I had more time. I'm not sure if I could finish this in about a minute, but if I could, you'd be able to see that these tests would pass once I actually have the appropriate solution. So like, so anyway, for the sake of time, I'm gonna continue going past this, but some of the exciting things are that you can actually, create this from a curated set of exercises where you can simply select them from a drop-down menu, some that have been created here, like from us at the NetsBlox, or on the NetsBlox team, or you could actually create yours. So this project is following a similar structure that we've seen with the service creation and some of these others, where we build this configuration basically that then makes this this auto grader available, and things like that. So let's actually start wrapping up because it looks like I'm basically at time. So the exciting thing here is that I think these auto graders being built in NetsBlox, then it should be easy to share, reuse, and remix. And of course, starting from a curated set of exercises should make it a lot easier to just compose them from things like these Caesar shift activities, or cracking a Caesar shift with brute force or partial solution, or for using frequency analysis, or a number of the other exercises that we've created. And in conclusion, really, one of our big focuses while working on NetsBlox has been really opening up the internet to make a lot of these other sorts of a lot of these sorts of integrations possible. So we can actually start easily accessing online data where we don't have to worry about massaging the data or API keys, and we can handle those behind the scenes. Distributed programs also open up another frontier for students where we can make programming more social. We can really motivate security in a way that wasn't popular or possible before. So then students will actually be interested in building their own, encryption algorithms or cracking their own. There's some of these encrypted messages, like in the case of robotics in particular. That one's one that certainly students get quite excited about. And it also makes it possible for us to start programming more devices. So not just running in the browser, but doing it, being able to program these voice assistants or these physical robots or virtual robots in a way that both motivates cybersecurity, but also can make it possible for students who don't have access to hardware or some of these other barriers that can make like programming in the age of Internet of Things difficult. And of course, we have other things, other features that we've added, like real-time collaboration, as we showed, to try to make it easier for students to work on these bigger and more complex problems, and make it so that people can actually extend it on their own through adding new services and things like that. And our real hope here is that by empowering students to create these projects with such a wider variety of interests, should make programming more relevant and hopefully more engaging for these students in these really early programming experiences. And of course, by making all this possible through just a couple of simple blocks and powerful abstractions. The hope is that we can still keep the environment simple, so it's not a bit of cognitive overload when they see blocks upon blocks upon blocks. With that, I'd also like to give a thank you to all the other people who have made this possible, because the team is certainly much larger than just Akos and I, especially through the years. There have been many people who contributed, including a number of grad students, a few which I think are on this call, and a number of different faculty at Vanderbilt, and a number of collaborators like Shuchi, Tiffany, Veronica, Marnie, Dan Garcia, Jens, and of course countless undergrad students, summer interns, high school teachers, and many students. So with that, I would like to thank you again for your time and attention, and I hope you guys enjoyed this this talk and these demos. Let me know if there are any questions.
Thank you so much, Brian and Akos. That was amazing. I know about 2/3 of the way through, my head exploded, and then you kept going and faster. But I'm really excited to know that this is recorded. I can go back and watch it later. I'm sure everyone will be joining me in doing that. So thank you so much for that.